inviting me. Let me know if you're seeing the right um, the right thing. Yeah.
Yeah.
Okay, cool. So right. So today I'm presenting some new work, two different lines of research that I'll talk about in a few moments. But first, for those of you who do not know me, as Steve said, my name is Almog. I'm an assistant professor at Ben-Gurion University. Not that long ago, I established the Computational Social Psychology Lab here at Ben-Gurion University, where we study how people engage with information in the digital age. So things like how humans make sense of truth, identity, and information in these algorithmically mediated worlds. And this means that a lot of social psychological phenomena, such as misinformation and polarization, are kind of folded into the things that I do and my lab does. And I think that one um, the today's talk will give some like this bits of taste of what this kind of work that we do that combines behavioral experiments and some computational work. And so, without further ado, I'll get right to the bottom of it. So. AI can now change minds, and I don't think that this is and this would be this would be overstated to say so. We have shown in our work with Steve, Fabio, and others in the team that AI systems can leverage things like micro-targeting to shape attitudes. We know that even brief interactions with AI agent now reduce belief in conspiracy theories, like Stella and colleagues shown. And recently, Kobe Hackenberg and colleagues have shown that information density is probably the strongest driver of AI persuasion among various predictors. So that means that when people are engaging with AI and the AI produces back things that are packed with a lot of information, they find, and their interpretation of those findings is that when there's a lot of information, this is exactly what makes people more persuaded by the information. The funny thing, though, is that when the AI is returning messages packed with information, the higher probability it does the probability rises for having misinformation in that in those messages. So it's interesting to note that while information is what being is what persuades people engaging with AI, it is very likely that a lot of this information coming from AI agents is not necessarily true. And what's I think that the main idea behind those papers and also ours before is trying to understand what exactly makes AI so persuasive. And this kind of neglects the other side of this equation, which is what makes people so susceptible to information from AI and what makes them persuaded by artificial intelligence. And hopefully I'll convincingly show in this talk that it's important also to look at what people think and how they engage with it. So from changing attitudes to changing belief, I'll be talking about two different questions. What processes enable people to change their attitudes after receiving information from AI? And that will be the first part of the talk. And the second part of the talk would be how people update their beliefs when AI conveys social or normative cues. So let's start with the first part of the talk. This is called Mind Meets Machine, Intellectual Humility, Trust, and Attitude Change in Human AI Dialogue. It was spearheaded by Deborah Newman, who's here. Oh, I misspelled your name, though. I'm so sorry. She's here, so hopefully she'll forgive me. And Professor Ruti Mayo from the Hebrew University of Jerusalem. So, why do people change their mind after talking to AI? Well, think about attitude change for anyone who studied, anyone embedded in social psychology knows that especially in political or moral issues, this is a hard task. People are not very easily persuaded or changed by discussing their ideas or beliefs or politics with others. And it seems like that short factual conversations with AI, specifically ChatGPT, can do this. It can do this in different contexts. And we wanted to understand what makes some people receptive to this AI input while others resist it. And coming from the research line by Deborah and Ruti, one of the things that we wanted to explore was that it's not about just the content of the message and the information that you gain from the message, but also it has something about the receiver's trait, and specifically about the trust in the technology and about intellectual humility. Now, trust in AI is what we broadly define as this belief that AI systems are competent, they are reliable, and there's trustworthy technologies that we can rely on their information. And intellectual humility, which is the other trait that here we will explore, is this recognition of one's own cognitive limitations and basically the willingness to revise beliefs when faced with evidence. So it's this inherent trait that I am open to other beliefs and I am open to changing my beliefs if I encounter good evidence when I see. And in the first study, we showed that conversations with ChatGPT about legal immigration could potentially change their attitudes towards legal immigrants. In this design, we had about 108 UK adults who were pre-selected to have negative attitudes towards legal immigrants in the UK. And we studied their baseline attitude towards legal immigrants and also measured that whether they trust or distrust ChatGPT. And they had then 4 rounds of conversation on the topic, asking, what do you think about legal immigrants in England? And afterwards, they repeated with the attitude measure, and we administered trust and intellectual humility scales. How does that look like? So this is an actual transcript of one of those back and forth with the AI. So this is how we ask the participants, well, in England, there's a population of legal immigrants. What do you think about this issue? And this person says that they hate it and they want them to be deported. And then the AI is being prompted to deliver facts back to the participant and says the following, right? I understand that you have strong feelings about this issue. However, legal immigrants play a crucial role in England's economy by filling essential jobs, contributing to taxes and supporting public services, et cetera, et cetera. And give some positive information about legal immigrants in the UK. The person says, I don't actually agree with you. And then says, it's okay, but legal immigrants often start businesses to create jobs and boost the economy. They fill important roles in the industry. And again, highlighting the positive nature of legal immigrants coming to the UK. And then there's this question of whether, wait, do they not take jobs away from our own people? And this is where the AI can actually give some information that I consider valuable. Well, first, it validates their concerns, right? But then it says legal immigrants often take roles in industries that are struggling to find enough workers, such as healthcare, agriculture, and technology. By filling these gaps, they help keep these essential services running smoothly, and they will start new businesses, et cetera, et cetera, et cetera. And then it asks for the AI for more information, like how many illegal immigrants are there really in the UK? And then it says that according to the records in 2023, 13% of the population are foreign-born residents. So this is the pipeline. This is how it looks like from the perspective of the participants. And this is what we find. So after this back and forth, you see that there is a positive change in the attitudes. The way to look at this figure over here would be on the x-axis, you see the the attitudes before they talked with the AI agent. Let me remind you that we had a cutoff, right, of negative attitudes towards legal immigrants, and this is why you see only up to the 3 in the Likert scale over here. By the way, if there are messages, I won't be able to read them. So please just jump into the conversation if you want me to respond, okay? Because I can't see the text during the talk. On the y-axis, you see the distribution of attitudes after the treatment, and here you can see the difference, right? And you obviously see how the difference is positive and increases positive attitude towards legal immigrants in the UK, which is nice. But what we had an hypothesis about is the mechanism through which this operates, which is about people needing to be trusting the technology, but also open to revising their beliefs. And this is exactly what we find. On the x-axis, we see the trust in AI. On the y-axis, we see the opinions about legal immigrants. And in the different shades, we see here in light green, low intellectual humility, in dark green, high intellectual humility, suggesting that what you actually need is to be high on intellectual humility, and also to be trustworthy to the technology, to have your attitudes be changed.
Almog, sorry, are those post scores, or is this movement? It can't be movement. It's post score.
No, yes, it's post course, but it is adjusted to the time one.
Adjusted to what? Sorry.
To the pre. So in the model, it takes into.
Oh, I see.
Right. The attitudes in time. But that being said, this is still just a correlation, as we showed that trust and buy into intellectual humility, this interaction predicts who changed their mind after talking with ChatGPT. But since we administered these, especially intellectual humility scale, only after they engage with with AI, we don't really know what causes what here. Is it the intellectual humility that makes people open and receptive to attitude change, or whether it's just the interaction and then being changed by their attitude being changed makes them more intellectually humble? And this is why we see that interaction. And also how durable is this effect? So to answer this, we had a pre-registered experiment with baseline measure of intellectual humility before the AI content, and have a follow-up 1 week later to test the persistence with a larger sample. So we wanted to establish whether this link between trust and intellectual humility predicts attitude change, not just correlates with it. And we had 3 time points. At the first time point, we have this pre-screen, the baseline measure. At the second time point, which is immediately after the conversation with ChatGPT. And then at T3, we have a 1 week later. So we use structural equation modeling to track the stability and these causal paths. And to show you the attrition of what and why it's was a problem or a challenge for us to get some respectable size sample, it's because we start quite big, right? We start with almost 1,500 participants, and we have some pre-screening that we're doing to make sure that they have negative attitudes towards immigrants, and they also show some trust or distrust towards AI. And then the T2 completers are about only 212. We then end up with the final sample size of just a bit under 200 participants. We have the follow-up, but this is it. But our main question is ending at T2. And I'm not going to show you the entire thing. It's just that we have this structural equation model. And the important issue about this one is that this interaction between intellectual humility and trust at time 1 is what predicts attitudes at time 2 when accounting for the attitudes at time 1. So this red arrow here is basically the same as what I've shown you before. And if confirming that the mechanism to change here is having trust in the technology, but also open and receptive to changing your own beliefs. And if you're asking yourself about whether attitudes towards legal immigrants remained positive a week later after the interaction with AI, the answer is yes. They remain positive when you compare them to T1. This effect size between T3 and T1 is about, it coins D of about 0.72, but it still decreases from just after the intervention. So to sum up study 1, persuasion underpins not only the content, but on the receiver traits. People change their minds when they trust the technology, but they're also open to being wrong. And these traits jointly predict a durable attitude change that lasts beyond this moment of conversation. So AI persuasion depends on this willingness to engage with evidence rather than this mere susceptibility to influence. It means that it's not just the information being delivered through AI. There's also something about our epistemic traits and our traits that makes us more susceptible to changing our beliefs.
Quick question, if you don't mind. Do you have the actual numbers of attitudes and their change between T1 and T2 for this study? Similar to the earlier graph?
Yes. So T1, it was by definition less than 3, and then in T3, I actually don't. Sadly, I did not put it in the.
Okay, that's fine. I'll leave it later. I'm just curious in terms of absolute shift.
Yes, that makes sense. So later. But just to give some context, I do remember that it was about 3 point something, and before it was 2 point something. Sorry about that. So coming back to where we started, we said there are 2 complementary questions: whether what processes enable change and after receiving information from AI, and how do people update beliefs when AI conveys social and normative cues, which is the next project that I would like to to discuss. So some of you seen this word before, though it's relatively new. And this was spearheaded by Louis Teitelbaum, a PhD student of mine. And we wanted to understand whether it makes sense for people to take an LLM's advice on normative or social things. And there are good reasons for why people should do this. We know that AI models are trained on vast amount of human-generated text, and it's considered to consolidate this collective knowledge. And some people have portrayed this as effectively functioning as the modal participants, right? It reflects these common beliefs, attitude, conceptions of people because it is trained on this vast amounts of data, and it distills this information or the beliefs. And this echoes this idea of Gordon and Steve's work about social sampling theory, that how do we change our beliefs? Now, this is I'm using this just as an example here, so it's not an exact one-to-one mapping to social sampling theory, but it does help me to to drive home the point, hopefully. So in social sampling theory, one has its own attitude, this private distribution of attitude, as you see here in the blue distribution. And there's also the distribution of the social norm. And this distribution of social norm is what the individual is sampling from their environment, creating this distribution of what they consider the social norm. And when they need to express an attitude, it's a function of their own distribution of attitudes and the distribution of the social norm. And one thing that came up to me is that when we're thinking of how we update our beliefs, when we're engaging in this prompting and chatting with AI, what we're actually sampling from the AI is not a sample of social norm, but a sampling distribution. And let me just unpack what I mean here, okay? So for those of you who took statistics, which is all of you, I guess, but still, let me have this refresher. We have, think about the attitudes or opinion in the population, where we have this distribution of attitudes. Now, when we're having this distribution of social norms, it's like we sample, let's say, 20 people and construct this distribution of social norms by understanding whether the opinions of our loved ones or people that are close to us. So here we have the population mean, which is with the mu here, and here we have our sample that we sample. This is how our distribution of the data looks like, and oftentimes the mean of the distribution, the data distribution is resembles the mean of the population, but sometimes it is a bit off because we sample from the entire distribution. Now, when we're taking those means of the data distribution, and we do this many times, we're constructing the sampling distribution of the sample mean, which means that every data point here is actually a mean from a sample over here, from the data distribution. Now, thinking again about AI and how it needs to aggregate opinions, you can think about communicating with the AI as this distilled version that each time is sampling from a lot of different data distributions and gives you a mean of a data distribution. So it samples from a sampling distribution because it aggregates across different samples. And one idea that comes out of this conceptualization is that if indeed talking with AI is sampling from a sampling distribution, one property of a sampling distribution is that it needs to be associated with a specific n, which is what is the sample size, the implicit sample size that the AI is actually sampling from. So it gives you an aggregate opinion of how many individuals. And this is what what we wanted to understand in this project. We had two specific hypotheses. One, that participants will update their beliefs of I'll show you the paradigm in a second, but they update their estimates of the population average more strongly when they show me an AI response than a single human. So basically, they would weight the AI response as give it more weight than a single human response because it's supposed to be a measure of an aggregation of different opinions, but also that people explicitly would say that the AI opinion is supposed to be worth a lot of individuals, thousands, hundreds of thousands, million perhaps, but implicitly, when behaviorally they will update their opinions less strongly. We didn't really know how to the extent to how much, but we figured it won't be thousands or millions. And the way we went about it was to give participants 40 randomly ordered European Social Survey questions. And these were Israeli participants here in the university, and they had to estimate the average Israeli response to a single item. I'll show you in a second an example. After guessing, participants saw one answer. Either we told them this comes from a ChatGPT or it comes from a single individual, and then they have the opportunity to update their beliefs. So it looks like this. What do you think was the average answer of Israelis to this question? How, for instance, this is an item from the European Social Survey. How important is it in a democracy in general that the government protects all citizens from poverty? And then they need, on the sliding scale, to provide what they think the average is. And then they're being shown either a response from a single individual or what we told them was a response of ChatGPT. In actuality, it was still a response from a single individual. And they needed to then update their belief if they wanted to. And we had this fancy Bayesian model that takes all this data into account and basically what it can do, it gets the implicit sample size of what the LLM responses is. And again, I remind you that what we thought is that people would give more weight to the LLM, but implicitly they will have less weight than what they explicitly said. So do you have an intuition about what is the weight of an AI response? It's a quarter of a person. So that took us by surprise. Uh, so people update their beliefs as if the AI is less than a single individual.
Uh, Hang on, sorry. Now I need clarification for that. So this one quarter is what you're inferring from your Bayesian model.
Yes,
This is not what people tell you.
right. I'll get to what people tell me in a bit.
Okay, but that means so they adjust less than if a person is giving them feedback or whatever.
If they think a person is giving them feedback, they adjust more.
Right, but isn't that counter to the whole previous study and all this other stuff that says people are more
Yes, it is.
susceptible? It is. Okay, good. So just wanted to check my sanity here. Okay.
Yes. But this is, again, this is a different domain. We're in the normative domain, right? What we see here is that an AI's response is worth a quarter of a single survey response from an individual, which again is not what we thought we would see. That being said, explicitly, people are still saying that AI responses worth a lot of individuals. So we ask them, AI is often described as aggregating information. In your opinion, how many people's opinions are combined into ChatGPT's response? The median is 1,000. The range is all over the place. And then we ask them, well, imagine that you had an option to choose between an AI-generated answer and the average of a set of human answers to a question like the ones you've seen before. What is the minimum number of human responses required in the survey for you to prefer their average over a single AI response? In other words, how many people you need to take their advice instead of an AI's response? The median here is 30. Now, this is incompatible, right? I mean, if people think that an AI's response is aggregating thousands, and then they say, well, I need 30 individuals to prefer the human response, it's still it's incompatible. And we see this, there's a positive correlation between how many people's opinions are aggregated and how many people you would prefer, but it's still people in these two different questions still give more weight to the AI than to the individual. It's just not the case that they behave that when they come to update their beliefs about normative issues. Now, as this paradigm also allows us to do something a bit different, which is to understand, because there's ground truth here, we can compute what is the optimal weight that participant should give to an AI response, right? So we don't know if the AI is really what it does is aggregating those thousands of individuals and it gives a true response that it's supposed to give you that it really gives you the population average. And turns out that our participants were right in not giving too much weight to the AI, at least in our setting here, because what we see is that the optimal weight that participants should give to the AI's response is 1.16.
Sorry, I need clarification for this.
Yeah,
This is estimated from what? From what people
we
think.
have data, right? We have the real norms because we're using the European Social Survey. So if we actually prompt ChatGPT and it gives us back what they think is the average in the population, then how much would it be? What is the optimal weight that we should give to an AI's response, at least in the Israeli context? In Hebrew, that would be 1.16.
Right, because then what? Then that would approximate the actual responses.
That would give you the optimal weight. Yes, basically, yes. Okay.
Okay. Okay.
So thinking of this, right? This is what the behavior of our participants was like. So if we had actually given them ChatGPT's responses, what they should have done to get the optimal score is to give it a weight of 1.60.
Okay.
So participants explicitly describe ChatGPT as aggregating the views of many people on average. Right? That it would be equivalent to about 30 responses. But their actual belief updating told a different story. When revising their estimates, they weighted it as a quarter of an individual. So people symbolically treat AI as having this broad authority or this aggregation of thousands, but empirically, its inputs is weighted as weak evidence. And coming back to this two paths of AI persuasion, I am still trying to figure out what we have here. It's not necessarily a coherent story, as these are two different these are two different works that generally speak about trust in AI and how we update our beliefs and attitudes. But in the first study, what we did was looking at interpersonal persuasion, thinking of how attitude change depends on people's epistemic stance and their traits. There's trust and humility and intellectual humility as the mechanisms for attitude change. But when we shift to this normative persuasion, AI is seen as a proxy collective. And here we see this weird divergence between what people explicitly say about trusting AI and how they actually behave. And again, this is still work in progress. And I would actually love your feedback here and how we can take this forward. And if you see some ways to ties these two currently disjointed research projects and maybe to a more cohesive research idea that I could then pitch to a grant, that would be a great feedback from you. So thank you so much for your time.